All right, so now that we know how to reduce fractions, we are going to do multiplying of fractions. How much, meaning what fraction of a whole bar is one piece? So there's one bar, little piece of a Hershey's bar. Well, that little piece is 1/12 of the bar. There's 12 pieces total. I've got one piece in red, so it's 1/12. What fraction of a Hershey's bar is outlined? Well, the green part, that's 3/12 because it's three pieces, but what else is it? It's one column of chocolate, right? So it's 1/4 of the bar. And that's 4/12, but it's also 1/3 because there's 3 rows and there's 1 row there. Now how about the red one? What fractions can you think of that would represent the red? There's 6/12, there's 1/2. What else? There's 2 columns there, right? So it's 2 out of the 4 columns of chocolate. So those guys must be equivalent fractions, and if you look at them for a minute, they are. Because for the top one, you divide both by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 3/12 is the same thing as 1/4. I just want to reinforce this with chocolate, even though we've already done it mathematically, because I just want to make sense all the way down. So let's say that we have 1/3 of a chocolate bar. In terms of chocolate, what does this mean? I know that you probably know how to do this mathematically, and that's not what I'm asking. In terms of the chocolate bar, what does that mean? Well, a lot of times when you see a multiply sign, you're going to say of. So that would be 1/2 of 1/3. Well, there's my 1/3. There's my blue. 1/2 of 1/3. That would be that part right there. How much is that? Well, that green has 2 pieces in it, so it's 2/12 or it's 1/6. You could either reduce it mathematically or just look at the chocolate bar and see that it's 1/6 of the bar. So we know that 1/2 times 1/3 must equal 1/6 because it makes sense in chocolate, and I'm sure you probably remember how to do this in math, but I just want it to make sense both ways. Here's our rule. If we're multiplying fractions, we just multiply straight across. So we have 1/2 times 1/3 is 1 times 1 on the top, 2 times 3 on the bottom, and we get 1/6. So mathematically, we just multiply straight across, but in chocolate it made sense too. Did we need to get a common denominator? No. Remember, if you're multiplying or if you're dividing fractions, you don't need a common denominator. So here are some problems that are a little bit more involved. Let's look at this first one first. So my rule tells me to just multiply straight across, 15 times 7 on the top, 28 times 9 on the bottom, and I absolutely can do that. It's absolutely going to work, but I'm going to have really big numbers if I do that right away. So rather than doing it right away, I'm going to look at the prime factorization. As you get used to this, you can do it without listing the prime factorization, but for now we're going to list it. So 15 is the same as 3 times 5, 9 is the same as 3 times 3, 28 is the same as 4 times 7, but 4 is 2 times 2. Now if I look here, are there any factors on the top that are the same as factors on the bottom? Once I multiply, I'm just going to have one top and one bottom. And if we look, I've got a 3 on the top and the bottom and a 7 on the top and the bottom. So if I cancel those before I do my multiplication, it makes my life so much easier. Otherwise, I would have had huge numbers and I would have been looking for common factors in there. Okay, next example. Now, before we just list out the prime factorization, and I am going to list it, but let's just look at things, try to anticipate what's going to happen. Well, I've got that 11 on the bottom, and I see 55 on top. And that 55 is going to have an 11 in it. So I'll bet I can get something to cancel there. Then that 9 and 18, they look like something's going to cancel there. If you can already see it, you can absolutely go ahead and do it. I'm going to list the factors for this one, though. Lots of factors. First thing we could cancel are those 11s. Then we could cancel those 2 3s in the bottom and 2 3s on top. And then look at all the 2s all over the place. We'll just go cancel happy on those. We have 15 over 2. Now you still could have taken 55 times 18 times 24, gotten some huge ginormous number, and then 9 times 32 times 11 for the bottom. It would have worked. It's just messier to simplify that way. Now how do I do this? 14 is not a fraction. Oh, but it is a fraction. Remember, 14 is a rational number because I can write it as 14 over 1. Now I multiply straight across. I can take 3 times 14, but look at it for a minute. Yes, 7 goes into 14, so let's simplify first. We get 6 over 1, which is just 6. So that is how we multiply fractions. We just multiply straight across, and we make sure that everything is in fractional form first. Dividing fractions. Now, if we look at our Hershey's bar, we could say that keeping the green part is like dividing the blue part in 2. So that's like 1/3, that's my blue part is 1/3, divided by 2. I know my answer is 1/6, but how do I get there mathematically? Here's my logic. 1/3 divided by 2, dividing by 2 is the same thing as multiplying by a half, so I get 1/6. And that logic, even though dividing by 2 and multiplying by half might make kind of a lot of sense, in this case, it might not make a lot of sense in general. So let's look at our general rule. If I have a fraction divided by a fraction, my rule is that I flip the second fraction and then I multiply. I'm going to have that written again on the next slide. This is a very common thing in math, to take something you don't know how to do and turn it into something you do know how to do. So rather than teaching you how to divide fractions all by itself, we're just going to turn it into a multiplication problem, and then we already know how to do multiplication. Two numbers are reciprocals if their product is 1. To find the reciprocal, I just flip. So I'm just taking the reciprocal of the second fraction and multiplying. 2 students in one of my classes had a high school teacher that taught in this little poem, which is kind of silly, but you know what? Silly is worth it if it makes sense and helps you remember. So multiplying fractions, that's no problem. Top times top, bottom times bottom. So that's how we multiply. We just multiply straight across. Dividing fractions, don't ask why. Flip the second and multiply. Did we need a common denominator? No, we won't need common denominators until we're adding and subtracting. So if we have 20 over 6 divided by 5, that's 20 over 6 times 1 over 5. Remember, 5 is like 5 over 1, so if I flip it, it becomes 1 over 5. Now I can take 20 times 1 for the top and 6 times 5 for the bottom, that's fine. But if we see what's common, 5 goes into 20 4 times. 4 and 6 have something in common, they have 2 in common, so I just end up with 2/3. Go ahead and pause these if you need to. Okay, 9 over 100 divided by 13 over 1,000. Flip the second. It does matter which one you flip. You have to flip the second. Now what's going to cancel? Well, 100 goes into 1,000. You can just look at the zeros. 2 of those zeros will cancel with 2 of those zeros. So I just have 90 over 13. And that is dividing fractions.